Okay, here we have our second piece cut out from the template, and note this other one I've cut from a bit of leftover 3-meter ply that I had, so that's just one full stretch. Here's the other piece where I've joined it using the backing plate. Now obviously where these meet, that backing plate's going to get in the way there, so I will need to sand that back or plane it back a little bit and then a bit of sanding. And if you've got two which have come from a 2400 sheet that you've had to join, then you're going to need to sand both of those back so you can get this to join with clearance on the bottom there. Now I'm going to clamp these two together while I shape them, just to trim a few little bits and pieces so that they match perfectly. And to do so, I'm going to put a piece of ply either side and then clamp them together, and that will just hold them so that I can sand out any inconsistencies between the two shapes and make sure they meet perfectly. Okay, you can see that now that I have clamped them to meet at the end here, there's just a slight difference on the end there. I don't know if that's going to, there we go, which I will sand back. And you can see that when I line them up at the top here, let's get that to focus, when I line them up at the top, that I've got probably about another millimetre here on the bottom that I just want to take away, and that's a result of essentially taking one and drawing the other from it. So you'll probably find that all of your subsequent shapes, sides, panels from your initial template will be slightly bigger because you're drawing a line around that template and then you're effectively trying to cut up to that line, so that'll result in about a millimetre slightly larger like this, which once I've clamped them together we can just sand back and make sure they match up perfectly. Okay, I've just shaped these up to match perfectly. The last thing I did was, you'll notice I've just taken a little bit of an angle off the bottom part of these inside shapes where they're going to meet at an angle. They'll meet at roughly a, let's actually have a look over here. So you can see they'll meet at it's a bit more acute than a 45-degree angle, but what happens is you end up with quite a gap here where the two 4mm pieces come together, and you need to fill that with something. So in this case, it should be a much smaller gap by just taking a bit of that material off there, and we'll see how we go when we join it up. So these are the plans for the bulkheads, and these you can do one of two ways. You can either look at the diagrams and the measurements and just draw them out, because it's just a series of shapes at right angles to the measurements given, and they're square. So basically, if we take this one, it's 160 millimeters across the top, and you measure down from the center of that to get the overall height here, and then at a certain height down here it's 94 millimeters, and you can derive that shape just by drawing it out. The other option is when you print these out, these will be to the correct measurements, so you can actually then just cut it out, put it onto the board here, and then trace around it. I'm going to try that approach now. But don't glue these to the timber here unless you don't plan on filling the armors with foam, which is what I'm going to do as a experimental design this time, to make them effectively unsinkable, but also the foam will sort of fill out any gaps. It will effectively stick to the plywood and join the material together, and save me from having to do a bunch of work gluing the insides, and essentially the ply just becomes a bit of a wrapper to protect the foam core, rather than having to really focus on them being totally waterproof and totally strong, because that foam inside is also going to strengthen it. It'll save me having to do a lot of epoxy work on the inside, or fiberglass work on the inside on the joins. So we'll get to that soon. Now I'm just drawing with red pen on here, but remember, if you're cutting around these shapes, that's probably going to give maybe 0.5 millimeter as you cut around it, and then as you draw around the shape, that's adding another 0.5 millimeter on. So just account for that as if this is the approach that you're taking, right? You want to, because otherwise everything's going to just end up, you know, a couple of mils bigger because of the fact you're tracing around a shape. So account for that when you cut them out and when you draw them. This is the transom, which I'm cutting out of a 89 by 19 standard bit of timber you can get. It's actually 90 mil across the top here, but the difference of a millimeter is not going to matter. This is what it was actually designed for. Makes it easy, and the reason I'm using an 89 by 19 rather than just a piece of ply is because it lets me fix the sides up against this to screw and then glue them. Otherwise I'd have to add on some kind of corner part material that would run the length of there. But also, if you want to run your outriggers as a void and be able to store stuff in there, and that's what creates the floatation, then it lets you put a drainage point at the very end in this material by attaching a drain plug, just a standard sort of plastic drain plug you can fit into this. And there is our bulkheads, as well as the transom for a single outrigger.